Hello everyone and welcome to a webinar on Embrace Digital Transition with Fully Integrated and Intelligent Data-Driven Plant Engineering Solution. Thank you for taking out time for this webinar. This is a GoToWebinar session. You can use GoToWebinar question pane or chat box to post your questions and we will address those at the end of session. We would like to encourage you to share today's webinar if you find it useful with your professional network within your organization or in your circle. Without any further delay, we would like to start the session by introducing ourselves, that is ITN Factory GmbH and Cadison. ITN Factory GmbH having more than 2 decades experience as an engineering solution provider for various process and plant design industry. The objective of ITN Factory has to develop the solutions which improves the project engineering efficiency. In addition, all the solutions are having built-in intelligence, integration, and customization flexibility. It also has a lot of functionalities and features which helps in reducing time and efforts for report generation and error-free deliveries. Also, the total cost of ownership is low as compared to the other solutions. Cadison is a fully integrated multidisciplinary engineering solution that combines the entire engineering workflow in one system and unites engineering data and graphics to deliver the latest updated information of the project. This automated technology, we used to call it as a I-square PIM, that is Intelligent and Integrated Plant Information Modeling. The core of Cadison is object-oriented technology, which makes it different from other solutions. On the top of this object-oriented technology, it has a modular architecture with single database for real integration. Cadison addresses the project needs with its integrated workflow and intelligent functionalities as well as meets standardization objective at an enterprise level. Cadison enables entire project lifecycle integration from proposal engineering to as-built stage. Its built-in application includes project setup and project document management along with the costing calculations. So let us discuss some challenges faced by process industry team today while they are working on the other tools which are available in the market. So the first is like absence of built-in database and user or document management system. So the absence of built-in database, it leads to rely on external third-party database like SQL or Oracle, which in turns lead to additional project costs. Similarly, the absence of user or document management system, it will lead to limit internal communication and collaboration within the team and lack of security and control of documents. Next is lack of integration and collaboration. So multiple system means multiple databases and multiple teams, which leads to redundancy of efforts and data inconsistency. Everyone today needs smart output and the deliverables, but existing tools which are only CAD based and only modeling software, which are ineffective in delivering such results. Another important challenge is like efficiency during design since they are using multiple tools. So there are lots of errors and inconsistency in data involved since there are multiple disciplines involved and the multiple teams involved. Next is lack of reusability and modularity. So reusability and modularity are very important aspects today. With this CAD based solution or non-intelligent databases, it becomes difficult to reuse the data to project to use its project efficiently. A lot of time is needed to redesigning the same plant or same unit, and that's why cost goes up. And last is lack of revision management. So the change management is also a very important aspect when different teams are working together. It helps to maintain the different version. So the lack of revision management, it will lead to the inaccurate submission of data to the end customer. So what's the solution for this? So today we are going to see Cadison, which is an intelligent and integrated object-based solution which addresses the most of challenges which we have mentioned. So let us go and see the solution a bit of technical. So this is the interface of built-in PDM tool, that is project and document management tool. which shows us existing databases and projects which are available in its domain. A user can create a new project structure, and this new project structure is consisting of different databases, projects, and different document folders. And inside these different document folders, we can have multiple different drawings. Furthermore, user management is very easy, and it helps to assign certain rights to every user depending on the profile. For example, we can assign user with administrative rights as well as the non-administrative rights. Cadison PNID proves to be a comprehensive solution for creation of intelligent PFDs and PNIDs, instrumentation diagram like hookup, calculation and report generation. So here a user can create intelligent PNIDs with attribute data such as pipe specification and catalogs. Also, we can generate instrument list. We can carry out some sizing calculations and costing calculations. Apart from that, a predefined quality check like logic analyzers are for carrying out the logical checks in the drawing. So let us have a look at a sample PNID created in Cadison Designer. This is the interface of Cadison PNID Designer, which runs on the top of AutoCAD. We have menu bars at the top, and there are some ribbons such as a diagram, 3D model and steel layout below the menu bar, from where we can place the objects in the drawing and create the PNIDs. Also on the left hand side, we have a dockable object manager which contains a vast library of objects required for the plant designing, and all these objects they are created depending on some standards like DIN, NC, ISA, etc. On the left hand side, we have this Cadison tree which shows the project structure, object and object links. Also, we have the filter structure view to display desired object in the project. For example, if we want to see walls which are available in this project, so we can create our own view and we can see all the walls which are present in the project or inside that particular drawing. Cadison has default templates or sheets for PNID creation, where we can select the sheet size like A0, A1 and so on, and also we can define the scale or unit of the drawing, and we can see that the title block gets generated into the PNID. Coming back to these vessels and nozzles, as we all know that like nozzles are always associated with the vessel, this child and parent relationship is maintained between the nozzle and vessel, which you can clearly see into this picture. Similarly, we can see the other components placed in the drawing like pumps. Pumps are also maintaining this child and parent relationship. Let us place some components from library, that is from Object Manager, into the PNID Designer using drag and drop function. Reference lines which we can see, it will helps us to place this object with the proper alignment at the desired location. Now once the components are placed, we will route the pipeline. So we have defined the medias required for this project, to which different pipe specifications and the catalogs are attached. Now using the standard pipeline dialog box, we will select the pipeline and we will choose the media. We will select the required pipe specification. We will select the nominal size and we will start routing the pipeline. So here first we will go with the suction pipeline, which will start from this nozzle and continue up to the suction side of pump. In a similar way, we can create the pipelines for the different routes which are available in the PNID. Once these pipelines are routed, we can complete these pipelines by adding various inline components like walls, instrument, miscellaneous components, etc. Cadison has a functionality of creating assemblies of group of objects known as construction set. which is stored permanently in the library, that is in the object manager. We have such construction set ready in the library. We will drag and drop this existing assembly or construction set into the drawing, and we will place it at a desired position. And once we are done with the assembly placement, we will update the drawing for getting desired results. In spite of being a construction set, it is an intelligent object and the data can be modified individually. We can also see that the catalog information is retained in the object. We have a function, object designation, which helps to designate the objects like pumps, tanks, heat exchangers or the pipelines with the desired configuration. So here we have configured the designation to view pipeline number, size, media and specification on the pipeline object. So using this object designation, we can tag the number of pipelines at the same time. Cadison provides built-in functionality for hookups, using which we can generate the hookup drawings of measuring instruments such as pressure indicator, level indicator, pressure transmitter, etc. So when we execute the command, a separate document group or a folder is created for these hookup drawings, from where we can open this drawing. Cadison provides multiple ways to edit and fill the data. In order to update the data in bulk quantity, we can select the data and we can export this data to the CSV or XML format. We can add the required information to these properties which are available in the CSV file, and we can re-import this file back into the designer. During the import process, it will ask you to verify the data which we have entered in the CSV. The data which we have added, it will get highlighted in a yellow color. Also, depending on our selection, this data will get highlighted in red as well as green color. And once we are done with this import process, the data gets updated into the PNID drawing. Cadison facilitates with logic analyzer features that consists of predefined logic checks. So here let's check for the uniqueness of equipment codes. We can see the error that two of the components are assigned with the same tag number. Even we can highlight the object to see the exact location. In case of number of errors to be solved in a large project, so we have logic analyzer container where we can store all the queries and update the wrong data in the container itself. Now after PNID is completed, we can generate the reports for the project. So we have this report generation wizard where there are number of predefined templates which are commonly required for the report generation, such as pipeline list, wall list, equipment list. We can generate the reports in Word format, Excel format as well as the PDF format. And then there are other recipients to segregate the reports type. So this is one of the sample example for the equipment list which we have created. Likewise, we can generate the number of reports under one document group. So in this way, we can list out the different objects which are used in the project. Moving ahead, Cadison 3D Designer proves to be a comprehensive solution for creation of intelligent layouts like equipment layout, piping layout, isometrics, GA drawings, calculations and report generation. Also, we have predefined quality checks like logic analyzer for carrying out logical checks in the drawing. So let us have a look at the sample 3D drawing created in Cadison 3D Designer. This is the interface of Cadison 3D Designer which runs on top of AutoCAD. We have menu bars at the top and there are ribbons below the menu bar from where we can place the objects in the drawing. Here we can see that there are different sections are available like foundation layout, equipment layout, piping layout and structural layout. Now we will see how to add the different types of vessels into the drawing. Tank Assistant is one of the ways of vessel creation through which we can create vertical vessel, horizontal vessel or special vessel. We can define the inputs for the tank components like shell, dish head, legs, etc. and can even save this configuration to use it later with all the necessary parameters which are required for this vessel creation. Also, we know that this vessel is already placed in the PNID drawing, so we can link that vessel to this 3D graphic. This shows that Cadison works as one integrated system and uses the single database. And then we can place the vessel in the drawing at the desired position, having all the intelligent data inside it. In order to provide pipeline connections, we will add nozzles to the vessel, for which we have Nozzle Assistant Wizard. So based on the type of surface selected, the Nozzle Assistant dialog box opens up, where we can feed the inputs for the nozzle as per the parameters shown in the figure. So choose the pipe specification, nozzle size, type of flange joint, and we can see that the nozzle has been created. Also, we can easily edit the nozzle once it is placed in the drawing. Now, after placing the equipments, let's create a pipeline. So there are many ways to create a pipeline in the project, and we will see them one by one. So we know that this PNID is already created, and Cadison works as an integrated system and uses the single database. So first we will go with the drag and drop option to create the drawing in a 3D layout. Here we can see that this pump is already created in the PNID drawing. So here we will utilize the same pump to create the drawing in the 3D. So we will just drag and drop this pump. So here we can see that the graphical objects for these pumps are automatically generated, and we can place this pump into the drawing as per the required coordinates. So now we will place this pump on the foundation. So here we can see that like this shows that a Cadison integrity function, and it helps us to synchronize the data within the different modules. In a similar way, we can create the pipeline. So let us drag and drop this pipeline from PNID drawing into the 3D drawing. So here we will see that once we drag and drop this pipeline from PNID to the 3D, this standard pipeline dialog box will open. So as this pipeline is already created in the PNID, this pipe specification and the medias, these properties are disabled for the further addition. Also here you will see two options. The one is like overlay now, and next is part wise pipe routing. So this helps you to route the pipeline. So first we will go with the overlay option. Here overlay option uses the single line representation, and with the help of this, here you can see that the pipeline will get created. Being a Cadison intelligent object, we have predefined connection points, and which help us to create the route for the pipeline. So here we have selected the first point of nozzle, and now we have created the suction side of pump. So here we can see that as soon as this route is completed, the 3D graphic for this pipeline has generated, And based on the direction, we can see that like elbows, flanges, gasket, etc. are automatically created. Now we will complete this pipeline by adding the inline components, for example wall. So again we will just drag and drop this wall from this PNID to the 3D, and we will try to place it on the drawing. So again here you can see that this automatic graphic has generated, and once we place this wall on the pipeline, so it will automatically create the counter flanges as well as the gasket as per the pipe specification which we have attached. Apart from that, once we are done with this object placement, we can move and we can rotate these objects on the pipeline. Now let us route another pipeline from pump discharge to the tie point. Again, in the standard pipeline dialog box, we can select the medias, we can select the pipeline, we can select the specification, and before clicking OK, we will select the checkbox for the part-wise routing. So a dialog box will open up which shows the piping components from where we can select the pipes and the fittings for the line. So when we start drawing the pipeline, the piping components are generated automatically, like flanges, pipe, elbows, tees, etc. And as we change the route by cursor, the command automatically predicts the next component as elbow, and we can continue the pipeline without any interruption. So in this way, we can instantly create the pipelines for our project. Now suppose if we want to create a T connections in between, then we can select the T from the dialog box, and the same is reflected in the drawing. So in such a way, we can manually select the components and complete the pipeline routing. Also, we can continue the pipeline from where we left off. So here we will continue with the T branch and we will route the pipeline. So we can see that based on the dynamic input, the pipes and the fittings are allocated to the cursor, and we can carry out this pipe routing till end. And this is how quickly we can reproduce this pipeline with the part-wise pipe routing command. Now we will complete the pipeline by adding walls to it. So we can directly select the walls from the catalog. So basically catalog is the set of data where we have defined the object properties, and based on the requirement we can configure the selection such as the types of drive like manual or pneumatic. We can select the spacer type and then we can select the wall. So here instead of having number of objects with different attributes and types, Cadison allows you to manually configure the object type. So this will help user in creating own configuration sets, and which can be saved in the library for the reuse. So we will place the wall in the pipeline, and being a Cadison intelligent object, the counter flanges and the gaskets are automatically created as per the specification used, and later on we can move or rotate the object within the pipeline as desired. After placing all these components, we will place primary supports on the pipeline. So we can choose the different types of primary supports from the catalog, and we can place it on the pipeline. So here we can see that we can configure the different types of supports. We can configure the material, and this configuration we can save it for the reuse. Once we place this support on the pipeline, so it will change the color of support, which shows that this support is linked with the parent object, that is the pipeline, and it forms a part of pipeline. And this support will appear in the isometric drawing as well. In the same way, we can place the rest of supports on the pipeline. And now we will move on to the isometrics. So Cadison has an isometric generation wizard where you can select the pipeline for the isometric generation. So here we can select the document group, we can select the sheet size and the title block. Also, we can preview the isometric before generating it, where we can check for the broken links or any errors in the preview itself. Then there is a checkbox for the 3D graphics, which will shows the 3D pipe in the isometric. So this will be helpful for the vendors at the time of fabrication, which will give us the clear picture of the isometric. So we can see the isometric file is generated with a clear view of weld symbols, tag numbers, walls, branching, etc. On the right hand side, we can see the bill of materials showing different materials and the quantities used. On the bottom left, we can see the 3D graphic of the pipe. In Cadison tree, we can see the isometric file which is being generated under the isometric document group. So once the isometric drawing is generated, the pipeline and inline fittings should not be modified. So user can lock the pipeline for the further editing. We have a setting in Cadison that as soon as the isometric drawing is approved, the pipeline can be locked for the further editing. A user cannot move or modify any inline component within the pipeline or attach any new catalog or even delete the components. This will help in protecting the pipeline from any unwanted modification. Now we will generate the GA drawings. With the help of Cadison section toolbox, we can define the area to be captured in the layout. If we filter the structured view in the Cadison tree, we can view the section box as an object. We can create the default template for the sheet where we can select the sheet size, title block, scales, unit, etc. And then we will just drag and drop this section box into the paper space. Then we are asked to choose the view direction, whether a top view, bottom view, front view or left view. So we will select the front view. As per the defined scale, the layout will be generated. We can see the viewport generated in the drawing as well as in the tree. In the similar way, we can place the rest of the viewports in the drawing by drag and drop method. Now, if we update the area of section box, the same will be reflected in the layout drawing by updating the viewport. So we can see that this viewport area is updated as per the changes in the section box. Now for labeling the drawing, we have object designation command where we can designate the object with the respective properties. Also, we can display the properties of a single object. Here we will label the pump with device tag number, where we can define some text orientations like horizontal, vertical, with leader, without leader, etc. And in a similar way, we can designate the other objects, for example, walls, vessel, heat exchanger, etc. After 3D drawing is completed, we can generate the reports from the project level. So we have this report generation wizard where there are numbers of predefined templates which are commonly required for report generation, such as bill of material, pipeline list, wall list, etc. are available. We can generate the reports in Word format, Excel format, and PDF format. Also, there are other disciplines to segregate the report types, such as plant design, electrical engineering, MSR, project management, etc. So we can try generating report for pipeline material list. So we can select the document group in which the reports will be stored. We can also change the file name if required, and we can see that the report will get generated automatically. All the relevant data related to the pipeline and inline fittings are displayed in this Excel sheet. Also, we have other data such as material summary and the bolt list, and all the pipeline and pipeline fittings which are present in the project, these are covered under this pipeline list. In the same way, we can generate the word report for the wall list for all the walls which are available in the project, where we can see that the wall related data such as tag number, description, material, manufacturer, and so on. Likewise, we can generate the number of reports under one document group. So in this way, we can list out the different objects used in the project. Also, we can pass on this information to the suppliers or non-AutoCAD users. Cadison provides you a functionality that allows you to quickly do the change management and the revision of documents. As Cadison works as one integrated system, so any changes carried out in P&ID drawing, it will be reflected in 3D model and vice versa. So let us take the example of this wall having tag number V076, which can be seen in 3D drawing as well. The same wall is also available in the GA drawing, and it is also available in the isometric drawing. So we can see that this tag number, that is V076, it is available everywhere. And if we open a already created report for the wall, there also we can see this tag number, this wall with the tag number V076. Now suppose if we receive any changes in the P&ID drawing, let's say like the tag number has changed to let's say V999. Once this change is carried out in the P&ID drawing, the same will be reflected in the 3D model. We can see that this device tag has changed to V999 in the 3D model. Similarly, these changes is carried out at the GA drawing as well. So here also you can see that the tag number has changed to V999. For reports, we don't have to create this report again. We will update the report where the revision of report will be created. We can add the revision text or comment as like wall tag number has updated. Then we can see the wall tag number is updated, and also a revision comment or revision mark A is marked on this report. We can update the isometric drawings as well. So if we select the same pipeline while generating the isometrics, it creates the revision and we can add the revision text, choose the document group, sheet size, and then the isometric revision is generated, and we can see that the wall tag number has been changed to V999, and also a revision is also created for the drawing. So if we filter the structured view to documents and revision, then we can see that all the revision files of the reports as well as the isometric drawings are stored into the project. As of now, we have seen different modules of Cadison like PDM, PNID Designer and 3D Designer. Also, we have seen their different unique features. Now let us explore one more interesting feature of Cadison, and that is the process documenter. So a process document helps us to create fast and accurate process documents from Cadison PNID Designer. So before getting into this feature, let's get some idea of this process documentation first. Process engineers describe a process with different measures in relation to the elements of the plant and its interconnected pipelines. So defining this entire process with all interconnected details is known as process documentation. Process documentation is the key for early stage of process engineering. We all know that a PNID provides the foundation of design on which rest of the project relies. In case of process documentation, this PNID diagram acts as a master document. During the operation phase of plant, these PNIDs can be visualized with details for the different processes with their process steps. For example, every industry has standard process documents for most of the processes like plant shutdown, tank maintenance, filter cleaning, etc. And in these process documents, every process step is displayed with different colors and line types in the PNID with various states of inline fittings for easy identification. Also, process engineers faces many difficulties in the task of process documentation. So the first, it is very time consuming task to highlight every individual component related to each process steps manually and assign them unigraphical properties for easy identification in the PNID. Secondly, we all know that PNID is not a constant document. It may get revised many times over the time, and it may get very difficult to adjust process document according to the updated PNID. Also, sometimes process engineers have to redraft the whole process document if there has been a lot of changes in the PNID. With this feature, we can overcome these bottlenecks and can create fast and accurate process documents from the Cadison PNID designer itself. So the first step is to define a process, then add the process steps required to carry out this process. Now we can attach the required pipe routes, fittings and equipments to the related process steps away. Once we have attached required elements of the plant, we can define their states like whether a wall should be open or closed for this process. After this, we can have a preview of each process step we have defined for the process. After defining all these steps, we can create a multi-page PDF document for our processes. This PDF document is exported outside the Cadison, and there we have our process document. So let us say there have been some changes in the PNID. So we need not have to redefine all the process steps again because it is getting saved inside your Cadison project. So we can always go back to the Cadison and make the necessary changes and again export the PDF so that we can have the updated process document with us for the further review purpose. To create a process document, we have to define some hierarchy, and this picture explains us the hierarchy. So on the top, we have project, which means that we can define these processes under the project. Under the project, we can define the various processes. A process will have certain process steps which must be executed in the sequence in order to carry out the process. And for each step, we can define the process way to which all the related piping components will be attached. So we can define the graphical parameters like color, line type, line width for each process way. Once all the process steps and its ways are defined, we can take the preview of them before exporting the process document. After verifying necessary things from the preview, we can export the process document with a single click, which will create a multi-page PDF file for our process. Now we will see this process in a detail. So the first we need to define a process. Here we have this sample PNID of mixing tank, where you can see that there are two mixing tanks with the tag number B001 and B002. Now we want to create a process document for the maintenance of tank B001, which is on the left hand side. So first we will start the process documenter, and there we have our project as a top node. And under this project we can create a process with the name tank B001 maintenance. Also we can add the description of the process as well. After defining the process, we will have to maintain the steps required for our process. So for maintenance of tank B001, now we will add some steps. So we will add these steps one by one. So the first step we will add, that is for the close water inlet. The next process step we will add, and that is for close CO2 inlet. The next process step, it will be for the stop agitator. Next step, this is for shut down outlet pump. And at last we will add a process step, that is for the close tank outlet valve. We have defined the process steps. Now the next step is to attach the required components of the plant to the respective process steps. Each process step must have a way, and all the required components can be attached to this way. So we will add a way under each process step, and we will attach the required component to them. So let us start with the first step. We are adding a way under this step, and this way will be attached to the required piping components. For these steps, the required components are pipe root of the water inlet and its inline walls and the nozzle of the tank. So here with this way we have attached a wall and a nozzle, and for them we can define a state like it should be open or closed during the process. In order to close the water inlet, we have to close this wall and the nozzle. Here we can define the graphical parameters for this way, like its color, line type and line width. So here we have defined our first process step with its way successfully. Similarly, we can add a way under all steps and we can attach the required piping components. Now we should define unique graphical parameters to each process step in order to identify them easily in our process document. Now we have defined all the process steps and the way for our process. We can have a preview of each process step before exporting our process document. So once we activate the preview, only the components which are attached to the selected process steps are highlighted with the different graphical parameters, and the rest of the PNID is grayed out. So we can easily identify the components which are relevant to our process steps. So here we can see that once we select any process step, it is highlighting the attached component. Now we can create the process document as we have defined all the process steps and the way. To create a process document, we just have to click a single button and it will create a multi-page PDF of our defined process. So it will plot each process step on individual page and it will combine all these pages into the one single multi-page PDF. So here we can see that the process document for our process, that is tank B001 maintenance, has created. Every time when we export a process document, so it will create a single file for each process and each process step will be on the new page in that particular PDF. In our process, we had 5 steps, so a PDF with 5 pages has been generated. On each page, the piping components related to one process are printed with the defined graphical parameters, and rest of the PNID is grayed out. So this is how we can define the different processes under our project from the PNID designer. If let us say some of the components are changed in the PNID and we just have to attach the updated components to the relevant process steps and export this process document again. So we will have our updated process document with us. So there is no need to have to recreate all these process steps or redraft the whole process document manually. For any organization, interoperability between the different engineering teams and the tools without any error is challenging task. Cadison has got you covered here as well. Its various interfaces enable seamless transfer of drawings and data, which allows user to easily integrate Cadison workflow into the current business workflow and supplement the existing investment of organization, keeping the total cost of ownership low. For example, here we can see that some of the third-party interfaces with the Cadison where we can perform IFC export IFC export import, scissor to interface for a trace analysis, and so on. So all in all, Cadison with its interfaces and interoperability creates a cohesive workplace for the better integration. So, what are the USPs and benefits that makes Cadison stand out among other CAD tools available in the market? So, the first is user and document management. Then we have better integration and parallel collaboration. Next is like greater reliability. Also, we have powerful checks and validation features, change and revision management, configuration flexibility, and of course, process documenter. We have covered all the points which can help you to digitalize your workflow. So, an integrated engineering software solution contributes to increase the efficiency and lowers the cost during plant design, planning, as well as during the operation. Digitalization and integration of entire engineering process are important building blocks for increasing competitiveness and the futuristic direction of the entire plant industry. So thank you for your attendance. Now we are open for the Q&A session. Please post your question in question pane box or and we will try to answer those questions. And also for more information, please visit our website. Thank you.